Hello everyone. Today I am going to discuss the Cpget 2021 mathematics previous year questions. In my previous video, I was solved some questions. So in this video, I will cover the remaining questions. So the question number 35 is, when will be the equation dou square u by dou x square plus x into dou square u by dou y square plus dou u by dou y is equal to 0 is elliptic. So whenever these type of question come in exam, whether it is elliptic or hyperbola or parabola, I will tell the for shortcut trick for these type of questions. So clearly the PD, this is a partial differential equation. The equation should be dou square u, that one only. So in general case, what I did, I just take the general case for this. So that is a into dou square u by dou x square plus b into dou square u by dou x into dou y plus c into dou square u by dou y square is equal to 0. So this is the general form of the PDE differential equation. So b square minus 4ac, whenever these b square minus 4ac is less than 0 is elliptic, and b square minus 4ac is greater than 0, that is hyperbola, and b square minus 4ac is equal to 0, then we can say that that is a parabola. So here is asking only elliptic. So I just use only these conditions. So if he asking hyperbola or parabola, you may use these conditions. So what I did, I just compare with this general case of a PDE equation with our question. So I get a is equal to 1 because dou square u by dou x square is the coefficient is 1 here. So the a is 1 and the coefficient of b should be 0 because that term is not present here. So the quotient of b is 0 and c is x because dou square u by dou y square quotient is x here. So after that what I did, I just substitute the values of a, b, c in this condition. So I get 0 minus 4 into 1 into x less than 0. So I just simplify that one, I get minus 4x less than 0. So whenever negative is this side, we can write as x is greater than 0. So in that case, the elliptic is possible, x is greater than 0. So that is the answer for this question. So whenever x is greater than 0, then only it is the PD equation is goes to elliptic. So the question number 36 is, which one of the following statement is correct? So you make sure about that he is asking correct statement or it is not correct statement. Okay. So try to read the question carefully. So whenever these type of questions asked, you may do in two ways. One is eliminating the discard the options, or you can directly identify the correct statement. So what I did, I just take the counter example for each statement. I just discard the options. So every bounded real sequence is convergent. He is saying that every bounded real sequence is convergent. So this is not possible because if I suppose consider the minus 1 power n, this is a bounded sequence, but it is not convergent because it is oscillating in between 1 and minus 1, 1 and minus 1. If you substitute the values of n, 1, 2, 3, 4, it is oscillating. So it is not convergent. So he is saying that convergent. So this is wrong option because we want correct statement. So every convergent sequence is unbounded. So what I did, I just take that 1 by n. This is the convergent sequence. We know that it is goes to 0. So clearly it is bounded in between 1 and 0. It is bounded in between 1 and 0. So this option is also cancelled because he is saying that unbounded. So it is bounded clearly. We can see that. So the fourth option is every Cauchy sequence of real numbers is unbounded. So we know that the statement in real line, every Cauchy sequence is a convergent sequence and every convergent sequence is a Cauchy sequence. So convergent sequence means it is bounded and monotonic. We know that. So he is saying that unbounded. So this case is also not possible. So the remaining option is only 3 is left. So 3 is only the correct option for this question. But he is saying that every bounded monotonic sequence of real number is convergent. So that's correct because if you take this as an example for this statement also, if you take 1 by n, it is convergent to 0 and it is bounded and it is monotonic because it is increasing from 0 to 1. So it is monotonic and bounded. We can say that the option 3 is the correct option for this question. So the question number 37 is, the sequence n divided by n plus 1 is. So he provided some options. that is monotonic increasing and monotonic decreasing and convergence to zero and divergence. So we just solve this question by using some conditions. So I just consider that sequence, given sequence as a n. So what I did, I just take the initial point for n equal to 1, I get that 1 by 2, and n equal to 2, I get 2 by 3. Okay, so I need nth term. So if I go to infinity, so I get that it is a 1. So we can clearly see that a starting initial point I get 1 by 2 and final point I get 1. So clearly it is increasing from 1 by 2 to 1, it is increasing. So we can say that this is a increase monotonic increasing sequence. So that is only the correct option. So it is monotonic increasing because we already proved that one, and it is not converges to 0, it is converges to 1. So it is convergence means it is not divergence. So that is only the correct one. So the 38th question is, which one of the following is not true? So you have to carefully, is asking the true statements are not true statements. Okay. So here the first option is limit n tends to infinity 3n plus 2n plus 1 is 3. He is asking not true statement. So if you apply the limit, if you take the common of n in denominator and numerator, you get 3. So this is the correct statement. But he is asking not true statement. So this option is wrong one. So if you observe carefully for these option, so the 1 plus 3 plus 5 plus up to so on 2n minus 1, this is a sum of all odd terms. So whenever sum of odd terms up to sum of n odd terms, we can say that directly n square as a sum of n odd terms. So in place of n, we just replace n minus 1 here. In place of n, we just replace n minus 1 here. So we get limit n tends to infinity 2n minus 1 whole square divided by n square. So what I did, I just took the common n, I get n square 2 minus 1 by n whole square by n square. I just cancel these two things. So I get limit n tends to infinity 2 minus 1 by n whole square. So after that, I just apply the limit, I get 2 square, and 2 square is 4, we know that. That is only the answer. So 4 is the answer for this limit, but he is saying that it is 0. So he is asking not true statement. So this is not possible. So we can take the answer because he is asking not true statements. Yeah, this case is possible, but he is asking not true statements. So we can discard the option. So the 39th question is, which one of the following series is divergent? So he is asking divergent series. So he is provided some series is summation sine 1 by n, summation 1 by n square, summation 1 by root n tan 1 by n, and summation 4 by n cube. So you in the time in series many tests are there. So you just remembering some tests. So I first of all I just take the first option and I am checking whether it is convergent or not. So we know that P series test, whenever this type of form is there and P is greater than 1 is convergent, P is less than or equal to 1 is divergent. So what I did, I just take sine 1 by n, and it is strictly, we can say that it is less than or equal to 1. Okay, so summation 1 by n is less than greater than sine 1 by n. So here the power of P is 1. By applying the P series test, whenever P is equal to 1 is clearly divergent. So we can say that by that sine 1 by n is divergent. So he is asking divergent statement. So this is only the correct option for this question. And you can clearly see that if you write 1 by n square here, so the P is greater than 1. P is greater than 1. So you may say that this is a convergent sequence. So it is also clearly 1 by n square. So by P series test, you can say that this is also convergent. It is n cube. So it is also convergent sequence because P is greater than 1. So by applying P series test, we can say that that three options are convergent sequence. One is divergent sequence. So limit tends to infinity x power n divided by n factorial. So what I did, I just write that x value as a less than or equal to 1. I get 1 by n factorial because minus 1 by, even if you write minus 1 by root n factorial. So if you apply the limit in both sides, both the left side and right side limits are goes to 0. This both are going to 0. So by sandwich theorem, we can say that this limit x power n divided by n factorial is going to 0. That is a direct statement. It is going to 0. So the option 3 is the correct option for that question. And 41 question is let x1 is greater than 1 and xn plus 1 is equal to 2 minus 1 by xn for every n greater than or equal to 2. So find the limit of the sequence xn. So whenever these type of questions ask, so I will tell you the one shortcut rate. So that is 41 question. The question is x1 is greater than 1, means the x1 value should be 2 or 1.5 whatever it is, which is greater than 1. So and xn plus 1 is equal to 2 minus 1 by x power n is greater than or equal to 2. So what I did, I just substitute the again another term n equal to 2. I get 2 minus 1 by x1. So x2 is equal to 2 minus, we know that x1 is greater than 1. So I just consider x1 as a 2. So I get that 3 by 2 and that is 1.5. We can see that here we consider x1 as a 2 and x2 is goes to 1.5, means the sequence is clearly decreasing from 2 to 1.5. Sequence is clearly decreasing. If you go through n term, so what I did, I just considered suppose limit n tends to infinity xn as a some limit L. So it is xn plus 1 also slight change, so we can consider both the limits as the same. So I get it L equal to 2 minus 1 by L, and if you did the LCM for this, we get L square minus 2L plus 1. So from that we get it L equal to 1 comma 1 at 1 comma 1. So clearly this sequence is going to decreasing and it is going, the limit value of this sequence is going to 1. So that is the correct option. Second option is the correct option for part 1 question. And 42 one is, which one of the following sequence is not a Cauchy sequence? I was already told you. So every in real line, every convergence sequence is a Cauchy sequence and every Cauchy sequence is a convergence. You can do by two ways. That's by whether it is a Cauchy sequence or by checking whether it is a convergent sequence. So if you checking, it is clearly convergent sequence, because if you took the numbers n equal to 1 to infinity, it is convergent to 1. So this is clearly convergent sequence. So this sequence is e power 1. So means it is e. So it is also convergent sequence. We can say that it is geometric series. If you take the r equal to 1 by n, r equal to 1 by 2, so it is strictly less than 1. So by applying the geometric series, we can say that this is a convergent sequence. So see, this one is not convergent sequence. So we know that every convergent sequence is Cauchy sequence. So the converse is also true. So this is not convergent, means this is not a Cauchy sequence. He is saying that not Cauchy. So if he is asking Cauchy, means the three options are correct. The third one is wrong. So the 43 one is, find the radius of convergence of power series summation n power n factorial x power n. So the radius of convergence, this question is very important, because many times this question is repeating. So I will tell you the formula and I will solve this question. That is, so the 42 question, the 42 question. 43 one, radius of convergence of summation n power n divided by n factorial x power n. So that this is a formula for the radius of convergence. So that is 1 by r is equal to limit n tends to infinity a n plus 1 divided by a n is equal to limit n tends to infinity a n power 1 by n. So I just use this part. So I consider the given, this one is a n. I get a n equal to n power n divided by n factorial. I just apply the n plus 1 terms in place of n. So I am substituting in the formula. I get like this way, and I just reciprocal for these terms, and I get n plus 1 power n plus 1 divided by n plus 1 factorial and n factorial by n power n. We know that n plus 1 we can written as a n plus 1 into n factorial, and similarly I just separated these two things. I get like this way, and I cancel the common terms, whatever it is there, these two terms and these two terms. So I get remaining part is this one. So we can clearly say that this is a e value. Whenever limit approach to n tends to infinity, n plus 1 power n divided by n power n, it is goes to e. So we want r. So what I did, I just reciprocal for this, I get 1 by e. So this is the correct option for this question. Correct option for 43 question. Yeah. See, from previous question also I was solved 42 one. That how the third option is not a causal sequence. See, so that is here I just consider as a an. So an is whenever the n terms is odd, I get n minus 1 by n, because the series terms are going like that way, and n is even means I get n plus 1 by n. So if I apply the limit, the both are going to infinity. So the series sequence is not convergent yet n plus 1 minus 1 power n by n. So we can say that it is not convergent, means it is not Cauchy sequence. So that way we can prove this is not a Cauchy sequence. So the 44th question is, which of the following Taylor series expansion is false? So we know that cos x expansion, this is a direct statement. So the cos x expansion, here we get 2n factorial, 2 n factorial, but he told that 2 into n plus 1 into factorial. So this is the here it is a correct statement, but he is asking false statement, means it is a correct statement, but there is a mistake from here. So that's why this option is correct one. So the remaining options are wrong. So by this we know that sin x expansion, e power x and e power x expansion. By this also we can say that this option is correct. So 45, define Fn mapping from 0 to 1 to R by Fnx is equal to Nx into 1 minus x square power n. So whenever the x goes to in between the interval 0 to 1 and n equal to 1 to 3, then find the limit value of n tends to infinity 0 1 Fnx dx. So he is asking this limit value. He is asking this limit value. He provided that fnx value. So I did like this way, that is, so he mentioned that fnx is nx into 1 minus x square into power n, and he is asking the limit value of this one. So what I did, I just apply the fnx value in the limit n tends to infinity 0 to 1, I get nx into 1 minus x square power n. So what I did, I just consider as a 1 minus x square as a t, and if I differentiate once, I get dt equal to minus 2x and dx, and here x is there and dx is there, I get x into dx value is minus dt by 2. So I just substituted those values from the this equation. I get t power n into minus dt by 2. So if I integrate simply, I get t power n plus 1 and n plus 1. Here I am not changing the limits, because I will substitute the values of t later. So I substitute the values of t is 1 minus x square into n plus power n plus 1 divided by n plus 1. The limit is goes to 0 to 1. So if I substitute the limiting value, the first term is goes to 0 clearly. If you substitute the 1 here, it is goes to 0. And if you substitute the 0 here, it is get 1 by 2 into n plus 1. Here negative is there and here negative will get. So negative negative will goes to positive. And here 1 by 2 into 1 plus 0. If you apply the limit, you get like this way. And the answer is 1 by 2 for this question. So 1 by 2 is the correct option for this 45 question. The 46th one is asking which one of the following statement is false. He is asking false statement. So you make sure about whether he is asking false or true. So you should read question carefully, and he is asking false statement. So we can prove. So the sequence of functions fn where fnx is n square x 1 plus n cube x square, x is from 0 to 1 is not uniformly convergent, and 0 to 1. He is saying that this statement is saying that this statement is not, means it is uniformly convergent. Then only we can pick this option as a correct one. Okay. So we have to prove this statement is a uniformly convergent. Okay. So if you apply the limit for this one, it is clearly goes to 0. So whenever any sequence or series is going to limit value is going to 0, means that is convergent sequence. If it is convergent, means we can say that bounded interval of that convergent sequence, we can say that that is also uniformly convergent. But he is saying that it is not a uniformly convergent sequence. So this is the correct option for this question. So 47 one is which one of the following series is not uniformly convergent on the interval minus 1 comma 1. So if I simply consider x as a 1 here, because our interval should be minus 1 to 1. So if I consider x as a 1, I get 1 by n square. So by p series test it is convergent. He is saying that series is not uniformly convergent. Okay. So if I consider x as a 1, I get 1 by n square. So this is also by P series test. We can say that that is convergent. And here also we get 1 by n square plus 1. If I consider x as a 1, so it is also convergent. So the three options are convergent, but he is asking not uniformly convergent series. So this is the correct option. This is not a uniformly convergent for interval minus 1 to 1. So the 48th question is let C belongs to 0 comma 1 interval if define f into 0 comma 1 to r by fx is he provided some function c if 0 to x and c to see if c less than x less than or equal to 1, it is given that the remain integrable 0 to 1 fx dx is 7 by 16. Then find the value of c. So he is asking the value of c and he provided the integration 0 to 1 fx dx is 7 by 6. He provided like this way, and the 48 answer is the function is given he provided that the function is from 0 to 1, 0 to 0 comma 1 to r, and fx is c 0 less than or equal to x, and like this way he provided. So what I did, I just substitute the fx values by using these limits conditions. So I get like this way, and we already told that the integration value of this is 7 by 16. So that's why I equated 7 by 16, and if you simply integrate that one, so we get cx from interval 0 to c and 2cx. If you simplify that one, we get quadratic equation. If you solve that quadratic equation, we get two values of c, that is 1 by 4 and 7 by 4. But he mentioned only one option, that is 1 by 4. So this is only the correct option. The c value is 1 by 4 for this question. So the option 3 is the correct one. So 49 is which one of the following statement is false. He is saying that which one of the following statement is false. So whenever these type of questions come, he may ask direct questions. So the composition of integrable functions is integrable. So this option is really wrong statement. So he's asking the false one. So this is the correct one, because by using the first fundamental theorem of calculus, we can say that the composition of integrable functions are not integrable. So he is saying that integrable. So the option is wrong. So 51 is let f be a bounded function defined on interval a comma b. Let p be a partition of a comma b. If p star is refinement of p, then which one of the following is false? So he is asking again false statement. Yeah, this is direct statement. So if you remembering the statements, this statement will not possible. So we can say that. So this is the false statement for this question. Yeah, and 51 question is define function from 0 comma 2 to r by fx is 0 if rational and 1 by 2 if irrational, and let a and b are the upper remain integrable and lower remain integrable respectively f1 0 to 1. So then which one of the following is true? So he is asking which one of the following true. So the solution for this question is little bit high by using the dot box in sum, and we can say that directly a equal to 1 and b equal to 0. So the upper limit is slowly going to 1 and the lower limit is slowly going to b 0. So that is the correct option for that question. The 52 one is directly, this is the basic question, we know that calculus. So the integration minus 1 to 1 mod x of dx. See, whenever these type of mod x questions are come, I will tell you one trick. So whenever these type of mod x questions are come, you don't do directly minus 1 to x. So if you do directly, it is goes to 0. So don't do like that. We have to break the intervals, because the mod x is not differentiable at a point of 0. Mod x is not differentiable at a point of 0. So there is a discontinuity there in discontinuity is there at the point 0. So we have to break the intervals and then we have to do the integration. So I just break the interval and I substitute x is 0 to infinity. So here the interval is only -1 to 1. So we can say that 0 to -1 to 0 as a minus x and 0 to 1 as a x dx. So if you integrate, we get like this way, and after that substituting the limit values, we get 1 by 2 plus 1 by 2, and if you do the LCM, we get as a 1 as a answer for this question. So one is the answer for this question. So many people did this mistake and they think that 0 is the correct option for this question, but that is not possible. So 53 question is integration 1 to 5 d divided by 1 plus t square dt. So we know that this is also the basic calculus question. So the 53 one is, so this is the question he mentioned here. So what I did, I just substituted 2 as a here. See, 2 has a here and 1 by 2 has a here, and I just integrated. I get, we know that whenever the function of derivative is in the numerator, we get that log. So log 1 plus t square as limit 1 to 5, and if you substitute the limit inside, we get log 1 by 3. We know that log x minus log y formula is applied here. We get 1 by 2 log 130. But I think there is a wrong option. There is no 1 by 2 here. I think 1 by 2. After that, they provided the answer for this question, I think. So that is not 1 by 3, 1 by 2. So there is a mistake in the option, I think. So 54 one, which one of the following sets is closed under the given binary operation? So this is a group theory question. So whenever these type of questions asked, so it is simple only, but you have to do for each and everything. So I will tell you how I done for the second one. So the set 1 comma 4 7 13 is a multiplication model of 15. So that is set, we have a given set like this way. So he is saying that multiplication modulo of 15. So what I do, I just take the powers because he is saying that multiplication modulo. If it's addition means we have to add 4 like that way. So it is multiplication means I just multiplying with 4. So if I write the power of 1, 4 power 1, I get 4. So the 4 is present inside of this, and if I write 4 square, I get 16. 16 is saying that multiple modulo of 15. So I get 1 here. So 1 is present inside of this. So similarly, if I do the 44 power 3, I get that 64. 64, if I apply the modulo of 15, I get 4 again. So the repeating the factors are we getting 1 4 1 4, that is only repeating. Those terms are present inside of that set. So it is possible for 7 also. If you write the power 1, we get 7, and 7 is present clearly. And if you write a 7 square, it is 49. So if you apply the model of 15, we get 4. And similarly 7 cube and 7 is 4. So you may check for 13 also, it is possible. For 1 it is clearly possible because it is a multiplicative inverse. So the option 2 is the correct one for these questions. So find the identity element. 55 question is find the identity element of the in the group 5, comma 15, 25, 3, 35 with binary operation multiplication modulo 40. So the question number 55. So he is asking about identity element. So we know that when we say the element is identity. So when we say element is identity, in general we say that whenever there is a binary operation here, so A star E is equal to E star A, it is goes to A for every A. Then we say that this E as a identity element. So what I did, I just took two elements directly from here, 5 and 25, and I just multiplied. Means I did binary operation here. So I get it 125. 125 under modulo 40. So if I done like that way, I get 5. So here A value get again A and 5 value get again 5. So the E is clearly 25. So 25 is the identity element in this group. So 25 is the correct option for this question. So 56 one, find the inverse of 13 in U14, where U14 is the set of positive integers less than 14. and relatively prime to 14, and U14 is a group under multiplication matrix. This is the direct statement. We can say that 13 is the self-inverse element in this group. So this is the basic question. So 56 one, and 57 one is find the number of generators of the cyclic group of order 8. So remember these type of questions. Whenever generator will come in group group questions, you can use the formula of pi n. Suppose group has a order n, and he is asking about generator of that group. You can use this formula pi n. So I just done that way. So he is asking number of generators of that group. So I just write pi n. So pi n as a formula for these type of questions. So here the n is 8. He mentioned that 8. A group has an order 8. So I just substituted value in place of n 8. So I get pi of 8 I can written as a 2 cube. And if you apply this pi 2 cube formula, we get 2 cube minus 2 square. And this 2 cube means 8 and 2 square is 4. We get 4 as a correct option for 57 question. 4 is the correct option for this question. So the 58 one is let A be the element of order n in a group and k be a positive integer, then find the order of an element a power k. So this is also direct formula and direct statement. So whenever these type of questions come, you just tick, you don't waste time, because in this exam the time is very less. In each question contain less than 1 minute. So the formula is GCD of order of A, order of G, comma K. So this is the direct one, and order of G you provided that n. So you just substitute that order of G, we get that n comma K. So this is the direct statement for this question. Option 4 is the correct one for this question. If D is a positive divisors of n, then find the number of elements of order D in a cyclic group of order n. So this is also direct statement. So you can say that the answer is pi d. Whenever the number of same order of elements are present inside of group means we can use this pi d. Whether if it is prime means we can directly do it. Even if it is not prime means we can change it as a 2 cube or 3 cube, whatever it is. So we get option 3 is the correct one for that question. And 60 question is he provided alpha as a one permutation group and beta as a BA2 permutation in a symmetric group SCI. Then he is asking just composition for these multiplication. That is very simple. If you do that one, you directly get this one. So 61 is find the order of a permutation of 1, 2, 3 and 1, 4, 5, 65. See, remember this question is very important. I think every time one question will come by using this order of permutation. So I will tell you the trick how to solve that one. So this is the question is asking the permutation group. So whenever the suppose if these two are distinct, so there is no common element in between this. So suppose if we asking the order of these two cycles means we can directly do it by using the applying this formula LCM of order of A and order of B. But he is asking the three permutations order. So there is a common element. One has a common element of in these two cycles. So we have to multiply first these two cycles, then we get the distinct permutation elements, then we can apply this formula. Whenever the order of permutation we get, I just consider as a tau here permutation group. The tau order is LCM of order of A and order of B, and here the cycle A and B are distinct. I mentioned here. So what I did, these two are common elements in these two cycles contain a common elements as a one. So what I did, I just multiply two cycles. I get 1, 4, 5, 2, 3. So you just multiply these two cycles, you get like this way. And after that, you can see that there is no common element in between these two cycles. So I just directly apply the formula. We know that the order of these cycle is 5 and order of these cycle is 2. So if you do the LCM for these orders, so we get 10 as a order of the permutation group. So the 10 is the correct option for these questions. I hope you can understand this. So 62 one is find the order of the alternative group A1. So we know that this is the basic question. Alternating group means the number of even permutations. The alternative group is set of all even permutations. So we know that in Sn factorial is order of Sn should be n factorial. In this Sn contain half of the even permutation and half of the odd permutation. So the even permutations we can call it as a alternating group. So that is An. Okay. So in this Sn the order is n factorial. Half means n factorial divided by 2 as a even permutations and n factorial by 2 as a odd permutation. So he is asking only even permutation. So then we can tick it as a n factorial by 2. So that is the correct option for these questions because he is asking the order. So 63 one is let Q be a group of rationals under addition. Okay, then Q star be the group of non-zero rationals numbers under the multiplication. Then find the number of isomorphism Q onto Q star. He is asking the onto subjective. So we have he provided two groups here. One is Q under addition. So we can say that this is a clearly group and Q star Q star means we are ignoring, we are removing the zero inside of that one, inside of Q. So under multiplication model. So he is asking the number of onto bijection. We can clearly see that the bijection is not possible here because this is there is no the function does not contain the subjective because if it is provided as a order n it is provided as a order n minus 1 because we can clearly say that we are removing the zero from these q star so it is not produce the whole set so we can say that it is not 1 also so there is no onto isomorphism happened here. So the number of isomorphism from Q onto Q star is 0. So 0 is the correct option for that question. So 64 one identify the Cayley's theorem from the following statement. We know that this is a direct statement. So the Cayley's theorem is nothing but a every group is isomorphic to the some subgroup of symmetric group. Okay. So he is saying that every group is isomorphic to the some permutation. Permutation group means symmetric group. So that is only the examiner is always trying to confuse you. The permutation group is Sn only symmetric group. So this is the correct option for Cayley's theorem question. So 65 one is 65 one. So given that H equal to set 1 comma 15 is a subgroup of G U32 then find the number of left cosets of H in G. So just remember whenever these type of is asking left cosets means we know that you already remember you can remember Lagrange's equation you know that Lagrange's equation say that number of left cosets is H in G we can say that yeah, number of left cosets H in G means order of group divides order of subgroup. So we just apply the Lagrange's formula statement. So order of G is clearly U32 and order of H is 2 here because it contains two elements. So I just apply that formula of Lagrange's one. So you get U32. U32 order we can written as a pi 32. Okay, that is only the number of elements contained in U32 we can written as a pi of 32 and 2 order has a 2 so I can write as this and if you simplify this pi 32 we get 2 power 5 minus 2 power 4 divided by 2. So if you simplify this one we get 8 as the answer for this question. So 8 is the correct option for this question. So I hope you can understand this one. If you really enjoy this video then try to like the video. Bye.